So I wanted to make a video tutorial to go with the written tutorial that I made on Twitter about how I made this neat sky occlusion system. How it works is there's a scene capture and it takes a capture of the entire screen to get the height, and then we can do some math to figure out if the ground is occluded by something above it. Like you can see this big cube, and um, below it, where it can't see the sky, it's masked out as white. The same thing works for particles and everything. And so, yeah, I wanted to try and make a quick tutorial showing how that's done. So we're just in the third person example scene. I'm going to very quickly kind of return it to the defaults. We get rid of that, and we get rid of this. And if we hit play, now we just have the normal third person scene. I've moved around some of these boxes, some of these shapes so that they're high off the ground so we can see below them, see if the occlusion's working. And I just added a floating particle system here with a bunch of particles that we're gonna, we also need to set this to, well, we can just leave that there for now. Okay, so first thing that we need to do is we need to add a scene capture 2D and add it to the scene. Now it needs a rotation of 0, -90, -90 in order to get the correct world space orientation that we're going to use later. And I'm just going to put it at 2000, 2000, 2000, which is approximately the center of the scene. And the height that you put it at is kind of arbitrary. You want it higher than most of your geometry, so you could throw it super, super high in the sky. But we'll just leave it at 2000 for now. And we are going to change the capture source to final color in RGB. And we are going to also go through all of these show flags, and we're going to delete, we're going to uncheck most of them. Just because we don't want the scene capture rendering things that it doesn't really need. We only kind of want the main meshes of the scene. We don't care about atmosphere or clouds or fog or anything. We just want landscape, skeletal meshes, translucency, nanite meshes, instant static meshes. We don't want bloom. We want to leave local exposure on, I think. Skylighting, dynamic shadows are off. All this stuff off. And we don't want game, we don't want lighting, but we do want post-processing. And so now if we create a render target for our scene capture to render into, and just name this guy Occlusion RT, and we drag this in here, we can see already I have it open in the other window with a whole bunch of other stuff, so I'm just closing that for a second. Okay, so if you throw in our render texture, you can see that we're already getting our scene being captured. So we want to change our render target format to RTFR32F because we only care about one channel, the R channel. We don't need RGB. And we can just leave this at 256 by 256 for now. We can make this larger to increase the resolution of our mask, but it also affects performance. Or you can go really low if you just need a general, broad, loose mask or whatever. Okay, so this is our render texture, and that's pretty cool. But we are rendering color here, and we want the actual world position height of all of the objects. And we could use scene depth, but there's some weird issues with it related to precision of capturing long range depths I've found. I also found an Unreal Engine forum post of other people explaining this, and the way they got around this is they make a post process. And what we're going to do is we're going to change this to post-process. And in our emissive color, we're just going to take world position, and we're going to mask out the height, which is the B channel, and just put this into emissive color and save. And now we can apply this post-process to our scene capture, and it's in render features, post-process materials. We choose this, and we choose PP world height, the post-process we just made. So now if we look at our render texture is showing the actual raw height, but the reason it's just pure red here is because values higher than 1, color values higher than 1 can't be visualized properly, right? Because how do you display a color brighter than 1 when 1 is pure white? So this is actually like 500 or whatever the correct height is, but it's just visualized as 1. So that's our height mask, and that's pretty simple and straightforward so far. But now what we have to do is we have to take this height mask and we have to do some shader math to kind of use it properly. So this is going to be sample sky occlusion material, and we're just going to throw this on the ground for now, and we're going to open this up, and we are going to drag our render texture in here because we're going to need that in a moment. And we're going to write a simple material that is going to take this texture, and it's going to align the UVs so that it lines up with where the camera was capturing. Actually, if we just visualize this right now, we throw it through a fractal node so we can visualize the values above 1 properly. We can see that something's showing up, but like underneath this cone isn't aligned properly. So that's what we're going to fix. We can do this with some pretty simple math. We just get the world position, and we get the camera position, which is going to be the position of our scene capture in the scene, which is 2000, 2000, 2000. And then we're going to component mask this to just be RGB, and we subtract these two. So now they're aligned properly, but we also need to scale it down to the right scale, and we scale it by the orthographic width of the scene capture. I see ortho width, which we forgot to set a few settings on our scene capture. This should be orthographic, and this should be whatever width you want. This determines like how far the extents of the capture is. So you can have this really close around the player, or you can have it larger. But the larger it is, like if you have it a really large range and your render texture size is only 256, then you're going to have some pretty large pixels for the texture. But we just do 10,000 for now, and so we put 10,000 in here, and then we component mask this to RNG because we only want the top-down projection of this in world space. And then we have to offset this just by half to center it properly. And so we plug this into the UVs and compile it. You can see that we are lined up perfectly. And we can grab some of these objects, we can move them around, we can put them up and down, and as it goes below the surface, you can see that it disappears. Which is great, right? So that's our alignment step. And then what we want to do is compare the depths a little bit better. Because right now we're just outputting the raw height, but we want to make a mask of 0 to 1, depending on if we are above or below something. And so we can do that with an if node, is one way to do it. And we just grab the world position dot B again, and we put that into A, and then we take our scene capture's height, the height that we captured in the texture, and we say if our height is if our object's height is larger than our render texture height, we want to return a value of 1, and that means that the pixel that we're trying to render is above something and it can see the sky. Otherwise, we just want to return 0. I may have that opposite flipped, and maybe the other way around, but ooh, what's that? That's funky. Let me take a look at my notes because I did something wrong. Oh yeah, so we actually want to subtract a tiny little bias here, just so we don't get Z fighting. And this can be just a tiny, tiny value, I believe. Yeah. So this just offsets the height from the render texture to kind of clamp it away. You can see it disappears around the edges first. There's like small adjustments to kind of smooth out the effect, whatever. Yeah, so you can play with that. And I did get this backwards, so let's swap these values around because we want a white mask where everything is below stuff. So yeah, and now there's our nice, properly masked material. So that's all fine and dandy. And if we put this on our particle system too, which actually I think we already have our my test material on there, but same thing. It works. You can see that the white particles are only underneath that object, and we can move this around. Cool, cool, cool. So that's the main effect. But the problem is that this region that we're capturing with the scene capture doesn't move with our player, right? This scene capture, that's top down. If our player was to move way off into the distance, the scene capture would still stay here. And we want this region to move with our player. And there's a few gotchas with that that we are going to fix. So the first thing that we're going to do is we're going to create a material parameter collection. And that's going to be useful for us to store some data that we're going to set via a blueprint, and then we're going to read it back in our sampling material. So sky occlusion, or MPC sky occlusion. And so we just want 2 parameters, I believe. We want a scalar that's called ortho width, and we want a vector parameter called SC position, I guess. This should be SC ortho width too. And we're just going to set this to our ortho width of 10,000 that we set over here for now. You could do this on begin play in a blueprint and set up these default values. We're not going to do that though. And next we're going to create a blueprint class that extends actor, and it's just going to be called Sky Occlusion Controller. Okay, so in this blueprint, we want to oh, it's not opening. Uh-oh. Of course, Unreal Engine crashes. Let's restart. That's annoying. Apparently that blueprint was too strong for Unreal Engine. Too strong. I hope we didn't lose anything. No, we're good. Okay, so let's try and open this blueprint again. There we go. Okay, so there's our blueprint. And what we want to do is add in our scene capture sky occlusion. This is a scene capture 2D. And we want to compile, and we will want to drag this into our scene, and then we want to assign our scene capture to it. Okay, and now what we're going to do is we are going to, every tick, get the player camera's position, and we're going to move our scene capture to that position. And then we're going to set that position in our material parameter collection so that our material can then grab that position and align the render texture to the proper position. So that's not too difficult. We can go get player camera manager, and then we can get camera location, and then we can break this because we only want the X and Y, and we want to keep the scene capture's Z value snapped to 2000, because that's where it currently is, or snap to whatever value you put it at. Scene capture, get actor location, break. And so those are our two positions, and then we just want to make vector with this X and this Y and the C. And then we want to take the sky occlusion and set actor location. And we're going to set it to this value on tick. And then we also want to set a vector parameter value in our material parameter collection sky occlusion. And we want to set the value as SC position. And we set the value as the new vector we made. And so that's great. And then if we press play, you can see that our texture is moving around. It's not aligned right anymore, though. And that's just because in our sampling material, we're still using this hard-coded value of 2000, 2000, 2000, when we should be using the new position that we moved it to and set in blueprints. So this we can grab with collection parameter. We get our sky occlusion parameter and our position, and we just swap that in there, which is great. And while we are here, actually, we could parameter collection. We could grab the orthographic width and just throw that in there too. That's the correct way that you'd want to do it instead of having magic numbers in there. But yeah, so we compile that, and we hit save, and if we're lucky and did everything good, there, we're aligned properly, but there's a super weird jitteriness going on, and it's kind of gross. And what's happening there is we are moving our scene capture to be in a spot that, because of the pixel resolution here, the scene capture is trying to like capture in between pixels, and it kind of like has weird pixel filtering problems. But we can resolve that pretty straightforwardly. There's a cool little trick that I learned, and what you want to do is, instead of just moving this to the exact position, we can move it to a vector snapped to grid position. So instead of having a value of like 0.3254128, we can just have like a value of 3. So we put this vector in, and then we pull that out to both of those spots again. And the grid size that we want is actually going to be it's going to be 1 divided by our render target size times our scene capture ortho width. So for me specifically, our render texture is 256, and our orthographic size is 10,000. So the value that we want to put in here, we can just do the math and it will evaluate it. We can go 1 divided by 256 multiplied by 10,000 and hit enter. It gives us a value of 39.0625. You could create variables for this, or you could even like get the values directly from the sky occlusion, right? You could go get component, and then you could get ortho width, right? And then you could also get target, texture target, and then width, size, get size X. Yeah, and then you could just do the math this way. But I'm lazy, and it's fine. And I'm not going to be changing this resolution. But since we already did this, let's just finish it up. So it's going to be a divide node. We're going to go 1 divided by 256, which is our render texture size, and then we're going to multiply this by our orthographic width, and then we plug this in, and it should be the same value. Can we see it? No, I don't think we can see it not in play mode. Yeah, now on tick, if we change that, or change any of these parameters, it will just automatically work properly, which is cool. But if we hit play, we should see that these are not working. Why is that not working? 1 divided by 256. Did I not compile? Hold up. 1 divided by 256 times 10,000. Does that work? Yeah, okay. If we hard code the value and it works. So there's just something a tiny bit wrong with this. And 1 divided by, let's actually run this for a second. Does it get evaluated? No, it doesn't get evaluated because it's not hooked up. Not in scope. Don't know what that means. target size. Well, anyways, I have another blueprint here, and this is what I'm doing. I get the target, I get the size, 1 divided by size, and then multiplied by the orthographic width. And it works here. Oh, it's because we're doing integer division, isn't it? Cast a float, and then we do this, right? Yeah, there we go. Gosh darn integer division. Yeah, so now this is perfectly smooth, and it moves around with our player. If we change the scene capture or the graphic size, everything should continue to work, but eventually we should see the things cut off from around us. Yeah, you can see how there's now a range. Oh, and it's not being aligned properly now. What the heck? I wonder why that is. Oh, it's because we're not setting the orthographic width in the blueprint too when we change it. So we actually want to set scalar parameter value here as well. We want to set our orthographic width just so that our material can read it in properly when we make the changes, right? So just like that, drag it in. And yeah, now that moves. And if we find our scene capture again and bring this down, you can see that the capture range is changing. And yeah, you can see that over there. As we get closer and farther away, it's because we're not capturing it because the scene capture doesn't capture large enough range around the player. So yeah, just set that to 10,000 and we're good. And so the only other issue is that we're capturing every frame, and that's kind of not super performant. And we probably don't need to, right? If we're just standing here not moving, it's still capturing every frame. And that's kind of a waste. Like if you have objects in the scene that move, like these things, right? And you want them to be able to occlude things in real time as they move, you kind of have to capture it every frame. But for things that don't move, like static geometry, cliffs, houses, rocks, whatever, it would be better to not capture every frame. And what I like to do in order to solve that is just store like a distance and say if the player has moved like 10,000 units away from the position that the camera was in when we last took a capture, take a capture again. And so that way it only captures once you move far enough away from your old position. And then, yeah, so let's take our scene capture and we disable capture every frame and capture on movement. And if we slide these over just a tiny bit and grab our scene capture, and just drag out a new copy of this variable, we can go capture scene. And this is going to say take a snapshot. And since this is on tick, it's essentially the exact same thing as doing capture every frame. Wait, what the heck? Why does not? Do we need this always persist rendering state thing on? I'm not sure. We'll take a look at that in a second. But so that captures every frame. But we're going to swap this around a tiny bit. We're going to add a new variable that's called last capture position. And this is just going to be a vector. We don't need to expose that. And then we're going to have a capture step. And this is just going to be a float. And we're going to expose this. And so now that will show up in our material, and we're just going to choose capture step to be like 50,000. And what we're going to do is say if we've moved 50,000 units away from our last capture position, take another capture. And that's not too difficult to do also. We're just going to move some stuff over to make some space. So if we get our last capture position and we get the distance squared, which is a little bit cheaper than distance, with our snapped grid position. And then we compare float. We compare that with our capture step. If our capture step is bigger, then we want to say, okay, let's take a capture and let's do all the rest of the stuff. And we can reroute that there. So we set our actor location, we capture the scene, and we reset our position and our orthographic width. But we also want to set our last capture position to store it for the next time we have to do the test, the distance check. So let's reroute that here. And then let's actually we want to have this over here. We want to set this position first, and then we want to reuse this position here and here. So we set the position, and then we set the actor to that position, we capture, and then we set our material parameter collections. And let's just add a print, just so we can see that how often our capture is capturing. So if we hit play, we can see that it's capturing, but it's not aligned. So I wonder if we do have to have persist rendering state. That seems to fix it. Yeah, okay, I guess it does. But if we just make this movable, just to see if this is working good. If we move this, there's a delay, right? Because our player hasn't moved, so it thinks that it doesn't need a new capture. But if we move our camera until we get another capture, it pops over to where it needs to be. So that's cool. And yeah, so that's how it works, I guess. That's all the info that there is. We can change our render texture resolution. We can drop this up to like 120 or 1024. And you can see that we get like sharper pixel resolution here. You can tell that that's more like a cone, but it's more expensive. And you can like drop this all the way to super low values, so long as it's large enough to capture the actual detail. But now it's like blobby. and it's like fine for some things, I'm sure. You don't need the resolution, but yeah. Ta-da! Okay, that's it. Feel free to ask questions or whatever if you need help or run into problems or whatever. Don't forget to smash that like button and subscribe. Okay, bye.